Hello everyone and welcome back to the channel. Today, we're going to build a complete Arduino project using multiple sensors and display their values on a 16 by 4 I2C LCD screen. We'll be working with the DHT11 temperature and humidity sensor, the LM35 analog temperature sensor, and a potentiometer. Let's dive in and explore each component, how it works, and how to connect everything with Arduino. DHT11 sensor. First, the DHT11 is a digital sensor that gives us both temperature and humidity readings. It uses a single digital pin to communicate with the Arduino. It's easy to use and perfect for basic environmental monitoring projects. LM35 sensor. Next, we have the LM35 sensor. Unlike the DHT11, this sensor only measures temperature, but it gives us an analog output. For every degree Celsius, the LM35 outputs 10 millivolts. So if we measure 250 millivolts, the temperature is 25 degrees Celsius. Potentiometer. And finally, the potentiometer. It's a variable resistor that will connect to an analog pin to read a voltage between 0 and 5 volts. We can use it to simulate a control or simply read the changing voltage. Let's now look at the Arduino code step by step. #include tells the compiler to include external libraries, code written by others. DHT.h library to use the DHT11 temperature and humidity sensor. Wire.h library to enable communication via I2C, used by the LCD. Liquid crystal _I2C.h library to control an LCD connected with I2C. #define DIT-pin 2 the DHT11 data pin is connected to digital pin 2. #define DHT-TYPE DHT11 we define that we're using the DHT11 model. DHT we create an object called DHT to handle sensor readings. #define LM35 pin A0 the LM35 sensor is connected to analog pin A0. #define pot pin A1 the potentiometer is connected to analog pin A1. Liquid crystal I2C, this is the type of LCD we use. LCD. We create an object LCD to control the screen. 0x20 the I2C address of the LCD, yours is 0x20. 16, for the LCD has 16 columns and 4 rows. This is a custom function to place the cursor at the correct spot on a 4-line LCD. Row _offsets, tells the LCD memory start positions for each line. LCD.command, sends a command to set the cursor at the right location. Setup, runs once when the Arduino starts. Serial.begin, 9600, opens the serial monitor at 9600 baud rate. DHT.begin, initializes the DHT sensor. LCD.init, initializes the LCD. LCD.backlight, turns on the LCD backlight. LCD.print, displays reading sensors. On the screen. Delay 2000, wait 2 seconds before starting the loop. Loop, this function runs forever after setup. Temp_DHT stores temperature from DHT11. Hum_DHT stores humidity from DHT11. ISNN, checks if the value is not a number, sensor error. If there's an error, display DHT sensor error and skip the rest. Analog read, reads analog voltage, 0 to 1023. Convert to voltage equals value * 5V/1023. Convert to temperature temp equals voltage times 100. Read analog value from potentiometer. Convert to voltage, 0 to 5 volts. LCD.clear, clears the screen. Each set cursor fixed, puts the text at the correct line. LCD.print, displays values for DHT11 temperature, humidity, LM35 temperature. Potentiometer voltage. Delay 2000, wait 2 seconds before the next update. When you're done, click the check button or the upload arrow. This will compile your sketch and generate a .hex file automatically. In the field labeled Program File, click the folder icon and browse to your .hex file. Select it and press OK. And that's it. Now you know how to export your Arduino code as a .hex file and use it in Proteus for simulation. This technique is super helpful for testing and debugging your projects without any physical components. If you found this tutorial useful, don't forget to like, share, and subscribe to the channel for more Arduino and electronics content. Thanks for watching, and see you next time. Goodbye.